So I'm going to do a quick video about the naming of triglyceride enantiomers, which is a little bit tricky at first. Um, so what I want to do is go through sort of the generic convention, and then we'll go over to some specific examples and understand what the difference is between glyceraldehyde 1-phosphate and glyceraldehyde 3-phosphate and how we could tell them apart. So let's begin by understanding that uh, the glyceride is built off of this molecule which is called glycerin or glycerol, which is a carbon, 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 and you can draw it like this with just OH groups sticking off of each one like this, and of course these positions would be taken up by hydrogen like this. Okay. And as you might remember from organic chemistry, this is sort of the Fisher projection model, which means it's the arms on the sides are coming out to hug you, and on the top of the bottom they're going back. So what this would mean is that we could also, if we wanted to, visualize this in this way with wedges, so coming out of the page for each of these substituents here. And it helps to do that in order to understand how we're going to name this thing. Okay, so this is actually already a prochiral molecule, meaning if we change something about it, we're very likely to get a chiral atom if we change something on either side here. So the way that we determine which position is which is we use this SN nomenclature. So we have this SN nomenclature. Now in the SN system, we just name each carbon with a number. So we have the SN1 position, and then based on the SN1 position, we then assign SN2 as the next carbon and SN3 as the carbon that's the furthest distance away from carbon 1. So that's fairly straightforward. Now the tricky part is just figuring out which one is carbon 1. And so we have to use this rule, which is that carbon, so the SN1 position, so the carbon 1 position is SN-1 is the pro-S carbon. What that means is if we promote the carbon, if we promote carbon 1, so if we call carbon 1 oxygen or nitrogen, or we call it something basically that has a higher priority, so that it's the second most high priority substituent attached to the central carbon, then that's going to be the that carbon which when promoted gives you an S configuration is the pro-S carbon. So let's use this as an example, and it'll make more sense by the end of the lesson here. So here's our central carbon, and everything is going to be based on central carbon. Okay, this is the central carbon. So based on the central carbon, we know that this is obviously going to be priority 1 substituent. It's the hydroxyl group. The oxygen has the highest priority of any molecule here. So if we're going to pick R or S chirality for this thing, the central carbon, we're going to use 1 as the oxygen. So let's take the example where we promote this carbon. Let's promote this to be the second highest priority substituent. And then what happens to our chirality? Well, we go from 1 to 2 and then around to 3 here, so this would be 3 automatically, right, because it's the last remaining substituent. And then hydrogen is number 4, the lowest one. Now we have this anti-clockwise rotation, but carbon is in the front, or hydrogen is in the front. So this hydrogen being in the front means that this configuration is the R configuration. Okay, and if the hydrogen was in the back, then this would be the S configuration, we'd be fine. But now we found out that this carbon is pro-R if we promote it. And there's only one other carbon, so by default, this one is going to be pro-S. which means that in our SN naming system, this carbon would be SN1, this carbon would be SN2, and this carbon would be SN3. So if we attach a substituent onto this carbon, it would be at the 1 position, so it would be a glyceride 1 substituent, basically. So let's get more specific, and let's go into a proper example and talk about this a little bit more. So as I said, all triglyceride enantiomers use the SN nomenclature system. So you can have two different orderings, right, where we have 1, 2, 3, or we can have 1 on the top, 2, and then 3. And let's see why each one is the way it is, just using this backbone without any substituents. And then we'll move on to a specific example down here. So this molecule we already looked at, right? So if we name this this substituent 1, if we let's in this case promote the bottom one, and we've already seen this molecule. We tried promoting the top one, and it was pro-R. So let's promote the bottom one. Let's make this 2, and this will be 3. So we go from 1 to 2 to 3, and this is the clockwise rotation. And because the hydrogen is the front, we know that clockwise will give us S. So this is S. If we promote this, we get the S configuration. And therefore, yes, this is the pro-S carbon. Therefore, this is the SN1 position. This is carbon 1. This would be 2. And this would be 3. Now over here, I want you to notice that the only difference between these two molecules is that we've switched the position of the OH. So we've switched the position of the OH. This is 1. Let's call this one 2. And again, we can do it arbitrarily, and all we have to do is identify which one is which. So we did it one way in the first example. In the second example, we did it the opposite way. So we just pick whichever way we want to do it. And this is 3. Let's go around this way. Okay. So now we have a clockwise rotation. And once again, our carbon is our hydrogen is in the front. So clockwise rotation with hydrogen in the front is S. So we have stumbled upon here since this is the one we promoted, this is going to be the pro-S carbon, which means that this is 1, so SN1, this is 2, and this is 3. So hopefully that sort of made sense about how we go through that and figure out which one is pro-R versus pro-S. Now we're going to look at this glycerol phosphate molecule. So we have glycerol 1-phosphate and glycerol 3-phosphate, and we're going to use this example, and we're going to understand which one is which, and it doesn't matter if you can see that. So let's identify what's going on here. So basically, we have this phosphate substituent in each case. So we have formed an ester linkage, right? An ester linkage between the oxygen and the phosphate. And what we need to figure out is what number is this carbon. And once we do that, we'll be able to name it glycerol 1-phosphate or glycerol 3-phosphate, because as you can see, these outside carbons are either 1 or 3. We're not talking about 2-phosphate here. So let's just go through the same procedure we did before. We start at the central carbon, and we go 1 for the OH. And let's try just promoting the carbon that has a phosphate on it. So this will be 2, and this will be 3. And let's move through a rotation here, and don't forget this is a hydrogen. Okay, and we find that we have a clockwise rotation. So we have a clockwise rotation, and the hydrogen is in the front. And as we said before, if we have clockwise with hydrogen in the front, that is S configuration. So this is an S configuration. So that means we promoted the right one, and this carbon is the pro-S carbon, which means that this is carbon number 1 or SN1 position, which means that what we have here is a molecule of SN glycerol 1-phosphate, or G1P. Now, we can just look at this other molecule, and since we flip the chirality center, we know that we're going to flip everything, and this is going to be 1, 2, and 3, and we're going to have glycerol 3-phosphate. But let's go through the motion since we're still learning how to do this. We'll call this 1, and let's make this number, let's make the other one number 2 here. Okay, and again, you can pick either one and you'll be able to figure it out. And this would be 3, and we'll just rotate through like this. And we have, again, we have a clockwise rotation. We have a clockwise rotation with hydrogen in the front here, right? So this is an S configuration. So this is an S configuration, and this is an S configuration. And the reason why this is important is because we promoted this carbon to get the S configuration, which means this is the pro-S carbon, which means this is carbon number 1, or SN1. Sorry about that. SN1. And so, because this is carbon number 1, we'll number it 1, this will be 2, and this will be 3. In this case, this would be 1, this would be 2, and this would be 3. And since the phosphate is on 3, we'll call this G3P. So this is a glycerol 3-phosphate. Okay. So I hope that helps, and if you watch the lesson back, you should be able to understand how you can determine the pro-S and pro-R configuration of a molecule just by looking at it in its Fisher projection. And then based on that, you should be able to name a molecule with a substituent, such as G3P or G1P, just by looking at which carbon the substituent is attached to. So I hope that helps, and if you have any questions or indeed corrections, please let me know.